So this is question 25. It's the first one from 9.3. All of the chapter 9 questions are from 9.3, but they're all a little bit different from each other. So I'm going to go over each one by one. So this one, sample size is 1923. Sample mean is 24.6. Standard deviation, 13 minutes. And mean commute time less than 25 minutes is the claim, and alpha equals 0.10. So those are all the key numbers that we need to use from here. Null and alternate hypothesis, I think you're all really good at this by now. For the null hypothesis H0, it's always going to be mu equals something, and to find which number it's equal to, you want something that relates to either the claim or can you conclude is another good key phrase to look for. What you don't want to put here is the sample mean, because that's what you're going to use later when you do the t-test. So here there's a claim that the mean commute time is less than 25 minutes. So H0 is going to be mu equals 25, and the alternate hypothesis is going to be mu is less than 25. And because it's less than, then it's left-tailed. So that's it for part one. You've seen and done that a million times before. This is one where it asks for the critical value, which is not what most of your homeworks have been, so I think you have less experience doing this. If it asks for the critical value, you need to know whether you're doing a z-test or a t-test, because that determines which table you need, but you also have a clue here because it links you to this table, and that's the one that you need to use. It's also table A3, so if you're more comfortable using the ones on paper, then you'd go to table A3. So first you need to figure out which row we're going to use, and the row is not sample size, it's degrees of freedom, so we need to find the sample size and subtract one from it. In this case, the sample size is a really big number, 1,923. The degrees of freedom only goes up to 200, so even when you subtract 1 from this, it's much larger than 200. And anytime you've got a number that is a lot bigger than 200, then you use this bottom row, which is Z, which basically just means a really big sample size. Then your alpha here is 0.10, and so you have to find that at the top of the table. But if so for H1, you have to go up and look at what symbol you used for H1 now. If it was less than or greater than, then we just use the alpha as is at the top, the 0.10, and that's what we have at this case. So we take the 0.10 and then we go all the way down. And so the critical value is where that column intersects with Z, so the critical value is 1.282. Or at least that's our starting point for the number. If we'd had it not equal in H1, then we would have taken the alpha value here and divided it by 2 to get 0.05, and we would have had our number be 1.645 instead of 1.282. The other thing you need to do is look at whether it's less than or greater than or not equal to before you enter in your number in the critical value. So if up here we had greater than, then it would just be the single number 1.282. In this case, since it's less than, we have to make that a negative number, so it's actually negative 1.282. And if we'd had it not equal, in which case we'd be using the 0.05 and the 1.645. There would actually be two critical values, the positive and the negative of these. So it'd be negative 1.645 and positive 1.645. Both of those would be the critical values. And it says if there's more than one, separate them with commas. So you'd type in the negative 1.645, comma, positive 1.645. But in this case, since it was less than, then we've got the 1.282, and then we make it negative. So negative 1.282 would be the critical value here. Now compute the test statistic. That's the part where we use the calculator. And make sure that the test that you're using matches the number or the letter that they ask for here. But all of 9.3 uses the t-test. So it's going to be stat, tests, and t-test number 2. And stats rather than data because we're not given a list of data to use. And so now we have to pull all the numbers out of the paragraph. Some people like to do this in advance on a piece of paper. And either way, the mean is going to be 24.6. Sorry, I put the wrong number there. That is the mean from the null and alternate hypothesis, not the mean from the data. So it's 25. The sample mean is what we put on X bar, and that's 24.6. The standard deviation is given to us, and that's 13 minutes, and N is the sample size, 1923. And then this needs to match what we said for our H1, which was less than, you probably don't have the color question. If you do, it doesn't matter. And calculate. And so then it gives us the T. Now, most of the homework problems you had asked for the P, so just make sure you're really paying attention to what they're asking for. And they're asking for the T, which is negative 1.349, 3 decimal places, so 1.349. And then when it comes to asking you whether to reject H0, now if the T that you calculate from part 3 is more than the critical value from part 2, then you reject. But if they're both negative, then you ignore the negative sign. So in this case, it's negative 1.349, and we're comparing that to the critical value, which was negative 1.282. So when we're ignoring the negative signs, 1.3 something is bigger than 1.2 something. T is greater, so we reject. And then for the conclusion, like always, anytime you say reject here, then you say there is enough evidence to conclude.